welcome to That Implementation Science Podcast, the show that aims to reduce the innovation to implementation gap to 16 and a half years. I'm your host, Mike Pullman, and on today's show, co-host Kevin King and I will talk with Pedja Klasnja about Agile science and just-in-time adaptive interventions, and stay tuned to hear a few of Pedja's critiques of the field. I want to send a quick trigger warning that we will discuss the subtle art of turd polishing. Along the way, we will quiz Pedja with several trivia questions about bikes, so stick around to play along. If you want to talk with us, we're on Twitter. I'm at ThatISPodcast, and Kevin is at KMKing_psych. I think you're really going to like today's show. Without further ado, let's get started. All right, everyone, welcome to That Implementation Science Podcast. We are here today with Pedja Klasnja. Pedja is an associate professor of information at the School of Information at the University of Michigan. He also works closely with me and others at the University of Washington Optics Center and the Impact Center. It used to be the Kaiser Permanente Impact Center, now is the University of Washington Impact Center, so I'm calling it UWIMP. I don't know if anybody else
There you go, UWAC and UWIMP.
That's right. Pedja studies mobile mental health, human-computer interaction, and implementation science. So some of the buzzwords you may have heard associated with Pedja include things like agile science, micro-randomized trials, just-in-time adaptive interventions, and causal pathway diagrams. We hope to talk about some of those today. So, Pedja, Kevin and I like to say that this podcast is about two people who don't really know very much about implementation science that are interviewing people who know a lot about implementation science. And half of the reason we're doing this whole thing is so that we can avoid having to read journal articles and just rather have people tell us the information instead. But you're actually not an implementation scientist, is that correct?
Exactly. I was going to say you have a wrong guest in that case, because I probably... I not claim to know anything about implementation science. I get roped into it thinking it would be one side project, but I'm still here a few years later. So at some point I'll need to learn a little bit about it. But so I'm not sure how much of help I'll be for that particular matter.
Well, thanks a lot, everyone. This has been Pedja. We're super happy to have you on the show. I hope you enjoyed and learned
nice
a lot
meeting you both.
Today. So it was great to meet you. And best wishes.
How did you find yourself kind of in this field? Like, how did you get roped into it?
Good question. So about 2016 and 2017, I was on a leave from Michigan. I was at Kaiser in Seattle. And Kara Lewis walked into my door one day and said, I hear you do these optimization trials. We should do something together. And I said, all right, let's sit and talk. And so we started writing grants together, and she brought in Aaron and you and Shannon. And originally, I think we wrote one grant that was the first submission of what is now the Mechanism R01 that Brian Weiner is on, and Byron Powell and a bunch of other people. That didn't go anywhere. I think it took us 5 tries to finally get that funded. But in any case, she kept coming back to write more grants with me, and she's a fantastic networker. So I got to meet a lot of really cool people like you, Mike. And so what I thought would be one side project ended up being about, at this point, maybe 30-40% of my work. And which means that at some point I do need to learn something about implementation science. I've been sort of pretending to be an outsider for long enough, but at this point, I guess it's been 5-6 years. I should learn a little bit.
I have to be honest, it's a really adaptive strategy in academia to pretend like you know nothing. I want to say Shannon Dorsey joined the faculty at UW in our clinical program. And no joke, for the first 10 years, she would introduce every comment with, well, I'm just new here and I don't really quite know what's going
That's
on.
Awesome.
Here's what I think.
So when it comes to implementation science, that's pretty much, I always say I'm outside of the field, but here's what I think. And usually that pisses someone off. Yesterday was Byron Powell that I upset a little bit.
Oh yeah? Well, how did you upset Byron?
We have a grant that, again, took about five times to get, that aims to develop these little micro theories of common implementation strategies. And so we've been going through a bunch of these where we sort of develop causal pathway diagrams for them and try to synthesize the literature about what the strategy actually is and how it works. And so Byron was presenting one yesterday, which was on tailoring strategies, I think is the name of the strategy. And I think he's been involved in some of these initiatives around systematizing strategies and so on. And I basically said, this is not a strategy. Like, why are we doing this? And it's, I think at one point I said something like, we should stop polishing turds in the field and to make them just a little bit more shiny, and he gets very upset. But the point is that, like, you know, if you're a infectious disease doc and you're giving people antibiotics, choosing which antibiotic to give and at what schedule is not an antibiotic. It's a part of treatment, but it's not the same thing as. And so I was arguing this is not a strategy, and there was some pushback.
Yeah, I want to come back to this idea of polishing the turd, because it sounds like you have a general critique of the field here, and I'm just interested in hearing more. If I heard you right, you said something like, we can't just keep polishing turds in this field and hoping for better outcomes. I'm probably putting some words in your mouth, but I'm honest. I'm really curious. Like, what do you see the field doing that you get frustrated by when you think about that?
Oh God! All right, so here we go. Since we're on the topic of upsetting other people, I think one of the things that, and partly why I've sort of stayed peripheral so far, that I've had a really hard time with, is this notion that instead of theorizing, we create just frameworks, which are basically just lists, laundry list of things, and we sometimes put those laundry lists in some small buckets. But I think that there's just a need for a lot more careful conceptual thinking about how things are working, and part of the reason that I'm continuing to stay involved is that these projects that I'm involved in are very much trying to do that, right? But I think sort of this shift from just classifying everything into buckets to actually trying to understand how something is working and having some precision around that, I think is really needed, and part of that might involve that actually saying that in this particular case, that facilitating the tailoring strategies is not a strategy. Like, there's some, if you add conceptual clarity, sometimes it means actually getting rid of some of the constructs that the field has had.
So in a way, it's I think if I'm hearing you right, you're arguing that we need more sort of theoretical development around constructs and measures. Or at least about constructs, like sort of what is a thing, what isn't a thing, how do we know if we're talking about the same thing? Is that what you're saying, or are you talking about something different?
Yeah, constructs and I would say processes, and certainly precision around measures comes as a way of getting precision around constructs, but trying to understand what is actually happening at a finer grain level, so that we can have an account of how change happens, right? And that a lot more of that is needed.
Great. So it's So I see. So it's both. I think about this from the measurement perspective a lot, even though I haven't done work on this perspective. Like when we measure something, we are also measuring a process. We're not just measuring something static. We give somebody a survey. Sure. They see the items. The items are a stimulus. They're making a choice between slightly agree and strongly agree, right? They're choosing between those buckets, and that there's some sort of process that's going on in their head, right? This has been talked about for decades in the measurement literature, although not often taken seriously. And you're talking about both. This is something that's thought about in implementation a lot when we're asking just how does it work, right? What's the process that's actually unfolding in the real world? I mean, I think that's, I think it's important, and it's also difficult in our field because I to my mind, at least, understanding all of the pieces that we're sort of wanting to throw into, whether it's, an implementation intervention, or whether it's understanding any scientific process, a lot of times we know parts of that really, really well. So we have a really good sense of what we think is happening, but then also we're often bringing in measures or constructs or settings that are way outside of our expertise. You might be applying something in a brand new field, like maybe you're doing something in cancer treatment, and it's like you don't know anything about cancer, but you know a lot about how people make decisions about treatment. And I'm just reflecting that that's always one of the struggles, is sort of getting a sense of I guess let me restate that. One of the struggles is like we often want shortcuts. We just want to say, oh, somebody else understands this, and so I'm just going to trust what they do. And I think it's a challenge to push back against that.
No, I think that's right. And the field is incredibly complex in terms of the settings in which these initiatives happen, in terms of the complexity of the initiatives themselves. So the range of contextual factors, organizational factors, and all of these things, in addition to actually expertise on the health condition that is being addressed, there's no question that this is hard. And that said, I think I'm not sure that what I'm arguing for is that you need that level of clarity for every single project. But over time, hopefully, the discipline can start moving towards to extracting some more general principles of how things are happening across projects. So we move to something that is more sort of, I guess, functional accounts in nature versus just categorization. Maybe that's what it is. That really thinking about not just naming things, but really trying to understand what is a process that is happening at whatever level we can get to.
I mean, I do feel like it's pretty standard for any relatively new field or science to begin with taxonomy as in classification. Yeah. This is true in biology. It's true in any area. And actually biology is kind of a nice analogy because, there are certain classifications that after decades of study, people determine are no longer the correct classification.
Yep.
And maybe it's sometimes that the classification definition has changed, or maybe sometimes it's the understanding of how a certain species evolved to reach there, impacts whatever their expression was, and that's changed the classification. And I think that's really where you're getting to, is that so far we've been doing a lot of taxonomies, a lot of classification and trying to define things and operationalize them. But once we really start thinking about how they interact and work together, that model that we've been using to sort of define them has changed as well, right? So this example you brought up earlier about sort of what's an intervention strategy versus or implementation strategy versus what's an intervention and how those two together may depend not so much even on how one or the other may kind of look in the real world as much as how one or the other functions in the world. And those are that's a more difficult step to reach, and a more difficult thing I think to begin to categorize. Yeah.
And I think to your point about the taxonomy sometimes having either being abandoned or changing as the functional understanding grows, I do think we're slowly starting to move in that direction with implementation science. So in a number of these strategies that we're mapping out as part of this R01, it looks like similar mechanisms are at play, right? And so potentially we can see the future 5 to 10 years from now, where really we're sort of defining things that need to be done in respect to the mechanism that needs to be activated. And it's possible that takes many forms. Some of these forms are going to get sort of branded and packaged in certain ways. Others are going to be more fluid, but the understanding of what is happening is going to be less determined by the form that is being provided and more by what it is that we're actually trying to accomplish and how. And but I do think that's the direction in general where we should be moving.
Awesome. Well, I mean, this has been one of the best experiences of polishing turds that I've ever had.
There you go.
So thank you for this. And I still can't get, Kevin's image earlier of polishing turds and putting words in your mouth. So two things just, difficult for me.
As I say often, Mike, I'm so sorry. So sorry.
Hey, so I realized we forgot something that's super important, is that we needed a name for our podcast. And I'm really curious if you have any ideas of what we should call this thing.
Well, given the discussion we've just had, one option would be a INET podcast, which is, it's not all terrible, right? There's a metaphor for the field. So, or if you want a more positive version, you can go with IROCS, which is implementation rocks.
Oh, nice.
But
I like that.
It's like advice to the first name.
Nice. Well, so some of the areas that you've been really working in, I'd love to talk with you a little bit about in particular, Agile science. And I wonder for those people who aren't familiar with it, if you could sort of just give a brief overview of kind of what Agile science is, why it's important to you, and how does it distinct from other things like human-centered design, implementation science, quality assurance, quality improvement, program evaluation. All of these things have a lot of things in common.
So Agile science is something that my colleague Eric Heckler, who is now at University of California, San Diego, and I have been working for a few years to try to basically come up with a set of principles that would help structure we initially were thinking of it in terms of intervention sciences, but I think there's a broader take here around basically early formative work and early evaluations of things that the interventions that we're designing. And the idea here was that we basically we wanted to optimize accumulation of evidence as well as accumulation of useful products. And so the question was how to do this early work. So most of our work was in the context of mobile health interventions. So how to develop mobile health interventions where we can start learning things that are actually transferable from one project to another, as well as build as part of this, because there's a sort of technology development part of all of this, build things that can transcend the life cycle of a single project, right? So that you actually are not just constantly throwing technology away when the grant is over, which is what happens most of the time, but actually be able to accumulate not just knowledge, but also some real stuff that can then be used going forward. And basically what we ended up doing is thinking of this as a system that combines elements of user-centered design in relation to things like ideation and sort of quick iteration through prototypes, with some of the work that Linda Collins has been doing in optimization to basically come up with a set of studies that are each intended to help solve a particular, to basically allow a person to make the next decision. And so the whole thing is set up as a way of supporting decision making through the life cycle of a project, optimizing for both reusable knowledge and reusable products. And what we end up with is this emphasis on, at least in the context of these mobile health interventions that we have been developing, focus on individual components as a sort of analytical units. So when you're sort of deploying a system, a lot of my work is in the context of physical activity and weight management, right? So we like in implementation, we develop intervention packages, right? So you develop an app that has a bunch of components. There's goal setting, and there's feedback, and there's planning, and there's sort of the activity suggestions and so on. And often it's sort of you can try to optimize the whole package. And a lot of the work that Linda has been doing in with most is around experimental designs that will help you decide which of these features you actually need to maximize effectiveness and minimize cost and so on. But the problem is that if you just do that, next time someone is trying to do an intervention, it's really unclear what do you take from the previous project, right? And so part of what we've been arguing for is that what you want to be doing is studying individual intervention components, and so we can sort of try to understand how does, for example, goal setting work in the context of physical activity, right? What are the variations that are meaningful to test? In what context and with what populations we can test those various variations, so that you can actually start accumulating evidence around modules that can both be technologically developed, right? So that there can be a goal setting module that someone else can then use in their own system, as well as sort of evidence that corresponds to those modules. So you can actually say, okay, if I'm trying to support patients following cardiac rehabilitation, right, who are living in somewhat rural environment, this is how you actually want to do goal setting for physical activity, because that we found that variation that adapts the goals in this particular way versus that way is actually more effective in this population, right? And so you can actually just take off the shelf piece then and say, I'm just going to plop it into my system and then move on to answer other questions that they have about this, right? So it's really about modularization across different levels, both modularization of evidence, that we can actually start building evidence for individual behavior change techniques, right? And both in terms of how they work in certain populations, and also sort of what are the various variations and what are the implications of providing, let's say, a gradually increasing step goal versus one that varies a fair bit from day to day, right? Part of that means sort of having some user-centered design around generating these various variations, trying to understand sort of which of these variations are theoretically interesting to study, and then having optimization trials, and this is where Linda's work on most comes in, that help you actually develop trials that can provide evidence for these particular modules that are being fielded. And so it's sort of optimization at multiple levels, both optimization of evidence as well as optimization of systems that we're developing.
Can I jump in with a question, Claire? I guess I'm just curious on the statistical part of this, the evidence accumulation part. Because this all sounds amazing, by the way, super cool, and I love the ideas here. And I guess the frame that I'm coming from is most of the trials that I have seen in implementation are pretty small. You don't have that many people in them relative to like the kind of work I do where we collect hundreds of people and run them through EMA protocols or get thousands of people for surveys, at the epidemiological level, right? A lot of clinical trials are really small. How do you think about the evidence accumulation and make sort of concrete decisions about what we think is working versus what we think is not when you always have this challenge of statistical power? So I'm just curious, how do you approach that? How do you think about that?
So just to be clear, most of this work that we have done on the mobile health side of things, not implementation science end of things, right? And so where we can actually get enough people, right? But power also, especially if you're actually starting to think about power in relation to individual components, it will look different, right? So if you're baseline randomizing something, then basically you calculate power the same way you would for a two-arm study, right? In the context of something like a factorial experiment, you still need a lot of people. But for example, many of the components that we're interested in are components that change over time. And so in which case we might use something like a micro-randomized trial as a experimental design to study these things, in which case the power ends up being in terms of the number of people that you need, ends up being substantially lower, although you will need more time, right? So for example, the very first study that we did using micro-randomized trials, there were two components in a physical activity intervention that we were studying. One was this sort of daily planning prompt, basic implementation intentions that asked people to plan how they would be active on the following day. And the other one were these highly contextually tailored suggestions that were supposed to encourage people to go for a walk in the near term after the suggestion is delivered, right? And so for the suggestions, we were randomizing that 5 times a day. So each person in the study for the duration of the study was randomized 5 times a day whether to receive the suggestions or not. And when you actually look at the power that's needed for something like that, we needed something like 28 people to be fully powered to actually
because you have tons of repeated
because you can tons of repeated
right?
Observations, right? So
Right.
Even in a 6-week study, you were looking at over 200 data points per person, right?
Right.
For planning, you have 42 data points per person, right? So even there, with 40 people, we were fully powered to actually study the effects of planning. So I think so that's one way you can think about power. The other way that we've been doing more recently is trying to think about what is the setting where we can ask at least some of the initial questions and get some of the initial evidence in a resource efficient ways. And so a student of mine, for example, he's been really interested in different types of displays, and especially feedback displays for providing physical activity feedback on smartwatches, right? And again, the question is like, you can actually generate a lot of different variations of these displays to just physically develop 16 variations if of a display and then deploy it. You would both in terms of resources for the development as well as resources for just getting the people to run that study. It's just not doable, right? And so we've been running web experiments, and then you can run a mechanical Turk experiment with 300 people, have a 4-factorial experiment across 3 factors, and actually get data that is at least for some of these initial questions around perception, right, meaningful. If your causal model is that this process you can study in simulation, then that's another way to deal with power, right? At some point, you have to move things into the field, but that doesn't need to be the first study.
Right, that's smart. And it seems like you're also taking advantage of this idea of the random effects experiment. I probably am getting the term wrong, but right, it's this idea that's been floating around, and it sounds like you've been doing it earlier than I've seen sort of a lot of people taking advantage of it, where basically instead of one experimental stimuli you sort of are actually exposing people to a whole variation of things that are supposed to represent maybe the same construct. Or in your case, you might be sort of deciding like which is the best, but you think they're all intended to do the same thing, but there may be sort of, you're able to, measure the strength of these different ones. So that's also kind of I just want to point out that's a cool facet of the things you're talking about. Is that when you do these repeated measures experiments, you can again just expose people to a whole bunch of different stimuli,
right?
And both you can get a median effect, right? As on average, when we expose people to this, screen, for example, what does it work? But then also, what works better than others? And that may be too much in the methodological weeds for a lot of our audience. But I just think that's a really cool thing that you're talking about. A really cool design feature. Yeah.
Aspect of that is really important when it comes to these interventions that actually people use, like mobile health interventions that they use throughout the day, is actually that these kinds of study designs also help you look at contextual moderation, right? So you can actually have time varying moderation effects where you can see that certain kinds of interventions work better, for example, when the person is at home versus when they're at work, or after, based on the dosage of other things they have received in the past. So there's a lot of granularity that you can of evidence that you get by just randomizing things repeatedly across different contexts, and then looking at how the effects are interacting with the situation that the person is in.
Yeah, cool. And the final thought I had just about the power, and when you're talking about the modularity of things, it also seems like you could use the evidence you gather across all these different contexts, whether it's your initial, it's an MTurk study to sort of say, okay, is there any plausibility to it, when we sort of get tons of people, or also even just sort of saying, okay, we have this module we've developed and people have adapted it now in 5 or 6 different implementation trials. It seems like you could use a meta-analytic perspective or even a Bayesian perspective where you sort of say, okay, how much is our prior changing, as we gather evidence, and sort of you can, in other words, you can use it to build off of rather than starting from zero and saying, okay, when we run our models, do we see a couple of stars next to our p-value or not? That seems really cool. That modularity buys you that.
And that's really the vision, right? That if you actually go down from the level of a full intervention package to individual components, then you can do those kinds of things. You can actually say, okay, so for this kind of component, across the studies that we've seen, the confidence in it working in this way versus that way, it increases. So you can very much use Bayesian techniques to move the evidence towards more sort of higher levels of confidence.
Does that mean then you have to convince the whole field to become Bayesians for you to really be successful in this? Because that seems like a pretty high bar to get to.
I don't think that's a prerequisite, right? I mean, I think that's some of these sort of additional ways of synthesizing evidence, I think, will emerge. But I think even just doing the kinds of studies that we have traditionally done in terms of how the data are analyzed would still allow some transfer of knowledge from one project to another, right? Because if you don't necessarily need to take my whole intervention and deploy it in another population. You need to say, okay, given that my population is similar in this or that way to these other studies that were done, and in all of those studies, this particular form of goal setting seemed to be effective, it's reasonable for me to try to use that form of goal setting in my next project as well. So I think in terms of, if you sort of, again, think of it in terms of decision making, that's partly what we're trying to do is to also allow for more informed decisions for future projects that really build on a more solid foundation than just sort of running massive meta-analyses across into whole intervention packages literature.
Cool.
Yeah, I guess I'm trying to sort of I might be missing something here, but when I think about sort of knowledge accumulation and hearing what you're describing, some of it sounds kind of similar to the distillation and matching method, which you're probably familiar with, Bruce Torpeda's work around, synthesizing the research literature to find what's effective across a wide variety of different disorders. So depression, super common disorders, depression, anxiety, et cetera. And then building these into sort of component-based interventions where they know which components are effective for which diagnoses, and clinicians are delivering them and able to sort of track that delivery over time and match it to the use improvement or not, and then change the components like in a sort of a real-time basis. That's my understanding. I may be wrong, but also, though, it sounds like you're adding a knowledge accumulation on top of that. Although maybe I misunderstood this, where you're talking about within person knowledge accumulation as well for the individual person who's going through, or is that not right?
Yeah. So, well, there's several things going on, I think, and let me come back to the within person issue, because there's part of the reason why we're actually doing these microrandomized experiments is to allow for within person sort of learning as well. But at the level of if we just think about sort of the field, right, and what you can learn in intervention sciences. So leaving implementation aside, like Susan Mikic has been doing meta-analysis of let's say interventions for physical activity and get management, and what you get is that things like the findings from there are that self-monitoring is really effective, goal setting is really effective, right? You get some. The question, though, is like with any intervention science, is like how in any given project, how do you actually operationalize those techniques, right? And when it comes to technological implementations, there are a lot of design choices to make, right? And so the level of just saying self-monitoring is useful doesn't really help me very much about how to provide self-monitoring, right? And so partly what we're trying to do is get at a slightly lower level or higher level of detail, I guess, in terms of the various variations at which these particular techniques can be deployed, and what are the differences in effectiveness in those variations, right? So and that can be both variation in terms of how the whole thing looks, right, as well as the variations in sort of the dynamics of provision. Knowing that planning is effective for increasing steps is great, but how often do I need to provide planning? Should I do it every day? Should I do it a couple of times a week? Right? Are there because there are differences in terms of what happens, right? People habituate to prompts, right? So they stop responding. Depending on whether how structured their lives are, planning may be more or less helpful and so on. And so partly what we're trying to figure out is like, can we get some evidence on those details of implementation and the context or the people for whom various kinds of implementations seem to make a difference? And I'm not sure that the kind of synthesis that we've done in the field so far really get to that level. Right, so that's part of it, and that is again tied to being able to actually have some modules that can just be reused, because the most efficient way to study this stuff is not to have to rebuild it every single time, right? So part of what we're trying to do is actually build a platform where you can have the off-the-shelf modules for some of these commonly used components with a bunch of dials, and you can just sort of say, okay, I want to configure it in this way or that way. Here's what is known about how those dials have been used in the past, and you can sort of try to say, okay, either I want to do different variations of this, or given what is known, this configuration of dials seems to be the best option that they have for the population that I'm trying to support, right? So I think the granularity is a little bit different than what you were describing. But the other part is around this notion of sort of learning within a person, right? And so Susan Murphy, who's a close collaborator of mine, has been doing a lot of work on using reinforcement learning algorithms to actually personalize provision of these interventions. So one of the things that you can do with the data from micro-randomized trials is actually set the sort of Bayesian priors for the policy of how these algorithms should work, and then adjust that for each individual person, right? So then the system actually starts learning from micro responses versus Pedja's responses, and adjust the provision to maximize the effectiveness for you versus me, right? And that means it might actually provide the same intervention in different contexts. It might provide it with different dose, right? Different frequency. It might turn it off for you altogether, right? Or sort of get it to a really low level if you're not responsive. And so the idea is that you might actually be able to really learn about how an individual person is responding to maximize the effectiveness for each person.
Mm-hmm. I think that's the future of science. Obviously, are these tailored kind of adaptive interventions to how somebody's responding, and mobile and digital tech, I think, provides an opportunity to do that. That's, I think, much more difficult from an individual clinician level. Although maybe individual clinicians, when they sort of talk about the art of what they do, that's kind of what they're talking about to some extent, is their own sort of knowledge about when to tailor. Although, as we know, clinicians are not very good at predicting what to deliver when and what's most effective. I am kind of reminded a little bit about that classic Dale Carnegie book about how to win friends and influence people. In the very first chapter, he talks about, I think, he's like, I love cherries, but when I go fishing, I don't put cherries on the hook. I put worms on the hook, right? Because fish love worms, right? And this idea of reinforcement, I think, too, is something that we've maybe not taken as much advantage of in clinical interventions as we need to. Just simple rewards, but rewards tailored to what the individual person wants and what the individual person is responsive to. And, we know that in other, like my Runkeeper app or whatever gives me a badge when I do a run that is longer than a run that I've done before, or what have you. And those things I find silly, but also ridiculously rewarding. I kind of am disappointed in myself at how rewarding I find those, and how I may go for an additional run because I want a badge, which is silly because nobody sees that badge because I'm not friends with anyone. And I do friends with anyone on, well, as Kevin knows, I'm not friends with anyone, or I'm also not friends with anyone on the Runkeeper app. And I do feel like in clinical treatment, we're missing a lot of that. We're missing a lot of that really like could be automated positive reinforcement for people to help them sort of achieve their own goals and help them along that motivational cycle.
Yeah, the actual reinforcement for people, it has been somewhat of a tricky area in mobile health, in digital interventions, partly because there is a lot of variability in what people find rewarding. And so some of the early work that I've done with a colleague of mine from Switzerland, Catherine Blondon, on diabetes management using mobile apps. Like, for example, a lot of these gamification constructs, people with type 1 diabetes did not want to hear about. Like, this is too serious of a disease. I do not want to turn this into a game. Right. We also find that sort of what kind of badges people find reinforcing varies a great deal, and like I don't respond to any of them. And I think the part of the problem at the level of digital interventions is there's just the space of things that you can provide is relatively limited in any given system, right? And so you're going to and so the system can try to learn among the available actions what might work for Mike versus me, but it's still very much limited to a set of actions that the system can support. In clinical practice, I think it's a slightly different situation because one can actually elicit what good reinforcement might be in a much more fluid way. When it comes to these reinforcement learning algorithms, it's actually the algorithm that's being reinforced. It's not the person, right? And in which case, in this case, right? So the way that the learning happens is that the algorithm itself has a reward, right? What in computer science they call a reward, but it's a metric of success, right? It might be that for a goal setting algorithm, the metric of success is that the person has met the goal, right? And that's what the algorithm is tracking. And based on the context in which the person is meeting and not meeting goals, based on the level of the goal that is being provided, the system will slowly learn how to adjust the goal level in order to maximize the goal attainment. But the reward here is really for the algorithm, not for the person.
I see. Yep. Okay.
So I want to, one of the things that you're kind of talking about, but I don't think you've directly talked about, well, maybe you have, but we haven't used these words, this idea of just-in-time adaptive interventions. And it seems like that's a lot of what that is a lot of what you're talking about with these sort of digital mobile interventions. As someone so my research is in the alcohol field, and I've done a lot of EMA work, and a lot of what we argue with our EMA work is, this is going to be perfect for just-in-time adaptive interventions. We'll be able to figure out when somebody's at risk for a heavy drinking episode, and bam, deliver them the right intervention at the right time for the right person. And you've been doing this in other fields or in sort of other scientific domains. Would you tell for an outsider like me, what are the mistakes we should pay attention to? What are the warnings that you want to give us?
I think you've summarized them well, Kevin, that basically the goal here is to provide support when the support is most needed and when the person is most receptive to receiving support, right? And the idea is that what you're trying to optimize is both the effectiveness of the intervention itself, as well as the sort of receptivity or engagement of the person, so you can continue to support them over time, right? So they don't just put the system to a drawer and forget about it. A key part here has to do with what's the information that you actually need to be able to provide just-in-time support, right? And so, some of Dave Gustafson's early work with Jedi, to stick with your setting, was sort of using geofencing to detect when someone is approaching a bar and then providing a coping suggestion there, right? What's nice about that setting is that as long as you can sort of map what are the commonly used bars, the actual information is passively generating. So you're not actually having to ping a person with an EMA question every 20 minutes to say, are you close to a bar? Are you close to a bar, right? Because whenever you have passive data that is meaningful, it really helps with creating these kinds of interventions because the burden on the person stays relatively low, right? There have been a lot of attempts to use EMA data for building Jedis as well. You get both a lot of missingness, right? But also the level of burden then increases substantially, right? And massively. In EMA questions that are really sort of observational, EMA studies that are observational studies where EMAs are really sort of how you're getting research data, you can pay people. But in an intervention, it's not sustainable to pay people on a per question basis or per questionnaire basis. And so I think one of the key issues is can you actually get information that is needed to really define what the just-in-time state is, and that often ends up being not that simple at all, right? The other one has to do with that a lot of these just-in-time interventions, sort of taking a broader view, are inherently sort of what we're referring to as push interventions. So we're sort of sending something to a person, often through push notification or certain kind of haptic feedback. And then habituation ends up being a huge issue, right? So the more you bug people, the less they start responding and paying attention to it. And if most of the intervention is really in the form of push notifications, it's really hard to maintain engagement with those kinds of interventions. And so part of what we've been trying to think through is sort of how do you actually change that experience in a way that allows for these systems to be effective over longer periods of time. So those are some of the big issues. The other part is if you are actually going to be trying, the notion of just-in-time adaptive intervention does not require algorithmic decision rules. You can have just perfectly sort of deterministic decision rules that you write out by hand. If the person is this situation, do this, or if they're in that situation, do that. They get much more both complicated in terms of what is actually involved in building one of these things, as well as potentially more sophisticated and more effective if you can actually build in some of these kinds of algorithms like reinforcement learning algorithms or model predictive control that system engineers use. So there is a sort of technical complexity to a lot of this, and many behavioral scientists are just not equipped to do that. So it ends very quickly becomes sort of a big science kind of project where there is really a need for large collaborations, where there is expertise on computer science side, there is expertise on sort of just software development side, which is slightly different, right? As well as you need a fair bit of statistical expertise to make sure that whatever the system is doing is actually analyzable after the study is over, right? So it becomes very, very hard to do this short of a sort of R01 level of funding, because there's just too many people that are involved in building these systems.
Or I mean, almost like center grant level. I mean,
the kind
of problems you're trying to talk about, right? Every time you see a sort of psychologist design like website or app or software, they're terrible, right? We are, as a psychologist, we're terrible at like graphic design unless we happen to have that talent. And it's the difference. It always strikes me the difference between the even like a textbook publisher's website for, I used to teach intro psych, and the websites they would develop were just an order of magnitude worse than what Google does or Apple does, and people are used to a certain level of design and interactivity. So that's just one example of, and I'm sure the textbook publishers have tons of money, and then we're trying to do this hire a part-time programmer to develop the interface for our own module. It's a real challenge. The thing you said sort of early on about passive sensing and the EMA demand. I mean, even when you pay people in EMA, if your EMA is too intensive, too long, some portion of people just stop responding. So it seems like there's a real confound or real dilemma in that a lot of, for psychologists at least, a lot of the ways we're thinking about risk and moments of risk for people, whether it's for drinking or whether it's for depression or suicidal ideation or binge eating, we think a lot about psychological factors, which are a real, it's been a real challenge, I think, to model them using passive data. And the thing that's really accessible for passive data are things like contextual factors, like who are you around, where are you? But maybe those are very relevant, sometimes, but they just all kind of tend to be not as strong predictors as others. So you sort of you're facing this challenge of the thing that's easy and low burden is also maybe not such a great predictor. And then I don't even know how to address the other question about people just stop responding too. Like that seems like a real challenge for these interventions.
Yeah. So one direction that Susan Murphy has a lot of hope for dealing with some of these problems is really building sophisticated predictors of these of the states that you actually need for just-in-time adaptive intervention. So if you can run a study with 100 people with really quite frequent and intrusive EMA and pay the hell out of them, right, to actually complete it, you might actually be able to build some predictors that can then be used in the system where the triggering is being done off of the prediction of these states, and you only ask new EMA when your confidence in these predictions gets really wide.
Yeah.
Right. And so that you're actually trying to the actual state for the algorithm is always just a bunch of predictors. And that might be one way to deal with it. But I think this broader issue that we're often using what is available versus what we actually need is sort of endemic to the field. The first version of the third steps physical activity intervention, on which we started piloting these micro-randomized trials, we have this notion that these activity suggestions, really, if you think about theoretically what they're supposed to do, I mean, they're really priming prompts, right? They're supposed to increase the salience of your commitment to be active, and over time, that should lead to a lot more sort of opportunistic physical activity throughout the day, and so on. But we can't get that salience through passive sensing. So what we do is we look at your step count in 30 minutes after you receive the suggestion. It's a terrible proxy, right? I mean, it's yes, there's sort of some contextual, I mean, a signal there that the thing had the near-term impact, but it only has near-term impact if you're not in a meeting or recording a podcast, right? So if I send you a suggestion now and ask you to go for a walk, even if you feel like you're really stiff and you could use a walk, you probably will not just walk off, although you might, right? A big problem with these interventions is sort of figuring out how do you actually get to the constructs that are meaningful outcomes of these provisions of intervention components that you can use to learn what to do next. And often those are in fact psychological constructs that you don't have any direct access to.
Right. It's really exciting, and it's also a real conceptual challenge for the field to move forward. Yeah.
And to a point about sort of measurement, we're increasingly thinking of these as all measurement error issues, right? So what trying to figure out, like, what are the various indicators that we can have for these latent constructs, and trying to really construct some kind of a latent measure of a latent construct that can be used as a reward for an algorithm, or that we can predict using a variety of different kinds of signals that are both sort of passively sensed as well as sort of elicited through some kind of usable EMA.
Right. It's been interesting. I've been dabbling in the passive sensing literature a little bit in the past few years because we've been collecting it with our some of our recent grants, and it's interesting to read some passive sensing literature where they say, we verified this objective measure of some psychological construct, and then you read the paper and their gold standard outcome was self-report through the EMA, which I'm a huge fan. I'm a huge defender of self-report. I absolutely believe if I ask you how you feel, you're going to, give me at least an impressionistic sense of how you feel, and I should trust that rather than an EEG. I like your idea of, instead of like privileging one kind of evidence over the other, we think of them as all indicators of some, latent construct, something unobservable, and we really try to build our understanding of how, when, and in what context are these passive indicators related to what people tell us, and vice versa, and how well, if we just have the passive data, how much could we impute what your state might be? Sort of, those are really fascinating questions, and I think we're just at the beginning of trying to understand that, at least in the domains that I'm interested in.
Absolutely, and there are a lot of really serious technical problems with this stuff as well. Where if you read the engineering literature on sensing, they will say, "Oh, we have this stress classifier that proved to be 94.5% accurate in co-pressor tests and things of that sort." The moment you put it in the field, it's just complete mess, because the sensors move, right? There are 3 sensors that are necessary. People don't wear half of them most of the time, and so what you actually get when you try to deploy these in real world contexts are very different levels of accuracy than even if you can sort of trust that the thing is actually sensing what you think it's sensing, which is typically a problem. But even if you can sort of hand wave and say, yeah, this is in fact stress, and just the numbers from the lab and the numbers from the wild are wildly different.
Yeah, or it's as different as, or a challenge. We've been using just passive sensing on mobile phones, and do they have an iPhone or an Android? And that just, the amount those environments are locked down. You reminded me of a paper in the field that came out who I love, and I really respect the authors, but it was one of these ones where they said, we could predict whether or not people were engaging in heavy drinking episodes with 96% accuracy. And then you read the paper And they got to 90% by just figuring out, was it a weekend or a weekday and in the evening or in the morning? Because people are mostly drinking on Friday and Saturday evenings. That's it's really time-locked behavior. And they got that other 6% from all the passive data. Now, I'm impressed. 6% is pretty good, but it's a little misleading, I think, to sort of say we got 96% when,
that's right.
You could get most of the way there just by asking what time of day and what day is it.
Right. And then the question is, like, if you actually need some intrusive sensing for those extra 6%, is it worth it, right? Or do you just go by the time of the day and the day of the week?
Right. And then do you need all of, is it really just in time and adaptive? You're saying at 5 o'clock, we're going to talk to you about, okay, you might be drinking tonight. What are some strategies you're going to use to avoid having a really bad hangover,
Apparently, Colorado ski areas have been inundated with 911 calls automatically generated by iPhones from people crashing, and they think that somebody's fallen down and hurt themselves badly. And I guess iPhones now have some automated emergency call for this. Yeah. Yep. Interesting though. I mean, I do like your idea, Kevin, of imputing data but using supplemental data, maybe with a subset of people. We were having similar issues, not for mobile usage, but for website usage, right? Where when people decide to leave the website, they leave the website. You no longer can collect data. You don't know why they left the website or anything like this, but you could collect data from a subset of people that you do a lab-based study on that maybe are using your website, and you can ask them these questions or collect additional information on, and then use that to impute, responses or guess reasons why the people who you collected passively the data on may have left or not. So all really fun stuff. I think we're going to transition now because we're kind of running a little bit low on time, but we'd like to do this pop quiz. Kevin, do you want to talk about the quiz and in particular talk about like what Pedja may win from the quiz? And then also maybe Kevin, can you tell us, has anyone actually taken you up on this prize yet?
Okay. I don't know why you have to undercut the excitement of the quiz prize before I've even offered it. Thanks. So I have taken up a habit in the past few years of leaving more specific and hopefully moderately clever out of office messages. And so we're going to provide you with a quiz, and depending on your success in the quiz, and I will warn you, the scoring is entirely unreliable. There's a tremendous amount of measurement error. It's hard to even know what the scaling is of these points. But if you win the quiz, I will write an out of office message for you the next time you're going out of the office. All you have to do is request it. So I can just give you an example to entice you. One of my recent out of office messages was, I'm out of office with limited access to email. I'll do my best to reply to your email when I return. And then in brackets, it says, auto-translate from Google. Kevin and his family are going to Legoland and staying in the Castle Hotel. It's not clear who is more excited, Kevin or the kids. That is your prize, and I will happily write an out-of-office message that is either clever or profound or profoundly clever. How about I start with the first question? No, so we understand that you are a cyclist, or at least you enjoy cycling.
I do enjoy cycling.
And yes. I have to ask, what kind of cycling? Is it road cycling? Is it,
road and gravel? Yeah.
Road and gravel, okay.
Yeah, a lot of really good gravel roads in this part of the country. So I like not getting killed by cars. So getting on gravel roads is helpful.
Fantastic. All right. So this hopefully should be easy to you. What is a cycling technique of getting into the slipstream of another rider? Is it rafting? Is it B, grafting? Is it C, drafting? Or is it D, crafting?
Even I know this one. It's C, drafting.
Okay, fantastic. That's well done. Okay, Mike, you can take number 2.
Very good, very good. All right, you are one step closer to getting this Kevin King, this auto reply in your.
That was worth 75 points for a correct answer.
Excellent, okay. Excellent.
All right, number 2, maybe a little bit harder. What year did women's cycling first feature in the Olympics? Was it A, 1976, B, 1980, C, 1984, or D, 1988?
Ooh. In the Olympics, 76, 80, 84, and 88. Is that what you said?
76, 80, 84, and 88. Right.
The problem is that all of those are Winter Olympics years.
Oh, this isn't a trick question. Is that true?
Yeah, because 84 was Sarajevo, which is the only one that so.
I believe. I think it's okay to share this. I believe there, sometime in the late 80s or early 90s, the Winter and Summer Olympics started being held in off years.
Okay.
I'm
All right.
pretty
Used to be
sure
held in
All
the
right.
same year.
they used to
In
be
that
held in the
case,
same year.
Okay. I did not realize that. In that case, I'll go with 1980.
Ooh, yeah. Yeah. So
Wrong.
you're a very progressive thinker. You're a very progressive thinker. It didn't happen until 1984.
That-
For bonus, any idea of how many years earlier men's cycling appeared than women's?
You know, I'll cycle a lot. I don't actually follow cycling sport very much, so no idea. But I would love to hear
92 years before.
earlier.
It took
All
92
right.
years for men's cycle, or so men's appeared in 1896, did I do my math right? And women's in 1984.
Well, given that last year was the first time there was a Tour de France for women, that took a little bit longer than 92 years.
Wow. Yeah.
So I have some additional information. According to the internet, the first year that we had summer and winter Olympics in different years was 1994 in Lillehammer, Norway.
Okay. I did not know that.
I did not
That
either.
is cool.
I did not recall what year it was. I just remember at some point in childhood, we started having Olympics more frequently. Okay, number 3. Oh, sorry. So you get a somewhat
0
disagree. You get somewhat disagree. I'm gonna switch between Likert and continuous scales for this. I might even throw a zero inflated one. Okay, so your total is 75 plus a somewhat disagree. Number 3, this is, by the way, true factor modeling, right? You have to accommodate indicators of all different measurement scales. So number 3, the type of cycle racing called Keirin originated in which country? Now this, I'll give you the spelling, Keirin, Keirin, and I might be pronouncing it wrong. I probably am. Originated in which, okay, well, wow. That is
nice.
plus 175 points for that. That is extraordinary. I was going to give you 3. Okay, for extra points, what is Keirin?
Keirin is a form of track cycling that basically single speeds the bikes on a wooden velodrome, and it's done in a very traditional way in Japan. There's a whole sort of initiation into the sport, and very, very few non-Japanese cyclists ever actually make it into Keirin. But it's a form of a track single speed cycling.
Wow, that's outstanding. I'm going to give you a bonus point of all of the time. So I think your current score is 250 minus somewhat disagree and plus and all of the time on a Likert scale. Mike, do you want to go with number 4?
Yes,
and then I have a bonus question for number 5.
Number 4 is, in what year did unicycle racing first appear in the Olympics? Was it 1924, 1972, 1996, or unicycling has never been an Olympic sport?
I want to go say that it was never an Olympic sport, but I would totally believe it if you said 1924. That for a period of time they actually did this. But I'll go with it was never an Olympic sport.
Ooh, you've done so well. Yeah, 3 out of 4. 3 out of 4.
3 out. Well, yeah. So speaking of 75%, I think that's enough to win the prize. This last one could be a bonus. By the way, you got 3 points for that answer, so you're at 253 plus all of the time. Okay, so the last one is, who was the Tour de France winner between 1999 and 2005? Who's the official Tour de France winner from 1999 to 2005? Now, you said you don't follow cycling competition, so maybe this is challenging, but...
Official to 2005. I mean, was it who was official and then stopped being official, or who remained official?
I stated the question and I stand by it.
I think Lance Armstrong was the official winner, but I think all of those got stripped off.
Wonderful. That's 3,000 bonus points. That's fantastic. Yes, the correct answer is it was Lance Armstrong. He officially was stripped of his title, and they did not name a replacement winner. I believe, okay. I don't know for sure, but I believe the specter of doping was so... The idea was that almost everybody in the peloton was doping, and so they literally couldn't come up with somebody. Right. It's probably exaggeration, but...
154th place was actually the true winner.
There you go. That's right.
All right, fantastic. Well, Pedja, you won our quiz. You really that was a masterful performance. And so you won the prize. I will happily write an out-of-office message. Next time you need one, just send me an email and give me a little bit of details about what your trip is about, so I can sprinkle some, and I'll send you at least one, if not two options.
Excellent. Thank you. Looking forward to that.
So curious, Pedja, if you had to give one or two of the most important implementation science publications that you feel kind of budding implementation science researchers should spend some time reading, what would those be?
You're asking a wrong person. Again, I'm not an implementation scientist, right? but that said, there is a recent paper that just came out on the conceptual model and the mechanistic model of facilitation that Byron sent out, that Amy Kilborn and Shannon was on, and Michael Parchman was on, that I think is actually probably a really nice example of the direction I think that the field should be moving in. And the paper is called, how is it called? It's called How Does Facilitation in Healthcare Work? And using mechanism mapping to illustrate the black box of a meta implementation strategy. And and mostly I'm pushing for that one because I think it's a good example of the form of theorizing that I think we want to see more in the field.
We'll make sure, by the way, to include that in the show notes for folks who want to check out that paper. Pedja, do you want to add any shout outs to special people in your work or personal life?
There are so many. And so I've been incredibly lucky that most of my work is actually with a broad range of collaborators. And so Susan Murphy has probably been the single most influential colleague that I've had. And her work is fantastic. Eric Eckler's work, I think, has been great. And then my implementation science posse, right? Mike, Byron, Brian, Shannon, and Kara have been fantastic. And I'm really glad that you guys have put me in this area, even in spite of some of the turds that are found occasionally in the field.
All right, Pedja, this has been such a fun conversation. I know that, you say you're not in implementation science, but your brain is so massive and you've got so much to add and really help with the field. And I feel like implementation science is one of those areas that is just super porous among many other areas. And we need kind of all of us involved. And so we're so lucky to have you. Thank you so much for being part of this podcast. It's been so much fun talking with you.
Thanks so much for having me.
Thanks so much for listening. I hope you enjoyed today's show. If you liked today's podcast, do all the things podcast hosts ask you to do. Post it on social media, subscribe, share it with your friends and implementation science colleagues, or use it to ensnare your non-implementation science methodologist colleagues into the field. If you didn't like today's show, I want to remind you that we do remote sensing interventions. Just because you're paranoid, don't mean we're not studying you. If you want to talk to us, we're on Twitter. I'm at ThatISPodcast, and Kevin is at KMKing_psych. All of the comments and opinions expressed during today's show are our own. They are well-reasoned and insightful, and therefore are probably not endorsed by our grant funders or employers. Thanks for listening. On behalf of Kevin King and Pedja Klasnja, we'll catch you next time.
Have we even had 10 guests? I don't think we've had 10 guests yet. We're
but
recording a whole
number
bunch.
6, but 9 out of 10 found it enjoyable.
Exactly.
It's just, it's an estimate. There's missing data. We're going to have to impute it later.